everyone, welcome back to RESHMI'S corner. Today we are here with our third class on real numbers. Last class we discussed exercise 1.1 and today we are moving on to the fundamental theorem of arithmetic. Now before we move on to this theorem, let's just recall a few definitions. First of all, let's start with prime numbers. Now what are these prime numbers? Prime numbers are those set of natural numbers other than 1 which has the factors 1 and the number itself only. So how can we represent our prime factors? We represent it as a capital P, which is a set of all natural numbers other than 1 which has factors 1 and the number itself. So they are set of 2, 3, 5, 7 and so on. Now what are the composite numbers? Composite numbers are the set of all natural numbers other than 1 which have at least 3 factors. So how do we denote the composite number? We denote it as capital C, and it is the set of all natural numbers other than 1 which have at least 3 factors. So which will be the numbers? They can be 4, 6, 8, 9, 12 and so on. So now we said what prime numbers and composite numbers are. Now let's define what a prime factorization is. Prime factorization is the process of writing a composite number in terms of its product of primes. So now we defined what is prime numbers, what is composite numbers and what is prime factorization. Now we move on to our fundamental theorem of arithmetic. Now what is this fundamental theorem of arithmetic? According to this theorem, every composite number can be expressed as product of its prime and this factorization is unique except the order of primes. Now this theorem would be more clear through an example. So let us go for an example. We are going to do the prime factorization of the number 60. How do we do the prime factorization? We find out the lowest prime number by which you can divide 60. So which is that number? 2. So how much you get? You get 30. Again, which is the smallest prime number, you can divide 30. That is again 2. You get 15. Again, which is the lowest prime number by which you can divide 50. That is 3. And you get the answer 5. Now 5 itself is a prime factor which can't be divided further. So what is the prime factorization of 60? 60 is equal to 2 into 2 into 3 into 5. So this is our fundamental theorem of arithmetic. Any composite number can be represented as the product of its prime and this factorization will be unique. That means there can't be any other factors for 60. But the order of primes can change. That is, it can be written as 3 into 2 into 5 into 2 or again 5 into 3 into 2 into 2. This can take any order but the prime factors remains the same. So that was our fundamental theorem of arithmetic. Now let's move on to HCF and LCF. What is the difference between HCF and LCF and how to find out this HCF and LCF? So now what is HCF? HCF means the highest common factor. Now how do we define that? HCF of two positive integer is defined as the product of smallest power of each common prime factor. So what is HCF? HCF of two positive integers is the product of smallest power of each prime factor. Then what is LCM? LCM is the least common multiple. Then LCM of two positive integer is the product of highest power each prime factor, no matter if it's common nor not common. So what is this LCM? LCM of two positive integer is the product of a highest power of each prime factor, no matter whether it is common or not common. Now these both will be clear through the example, that what is the difference of HCF and LCM. So let's move on for an example, and the example is to find the HCF and LCM of 24 and 32. Now, how do we find the HCF and LCM? By the prime factorization. So, let's first do the prime factorization of 24. Now, which is the lowest prime number by which you can divide 24? It's 2. You get 12. Again, it's 2. You get 6. Again, it's 2. You get 3. So, how can we write 24 as? 24 can be written as 2 cube into 3. Now let's find out the prime factorization of 32. So 32. Now again, which is the lowest prime number by which you can divide 32? Again, it's 2. You get 16. Again, by 2 you get 8. Again, by 2 you get 4. Again, by 2 you get 2. So what is 32? You can write 32 as 2, 1, 2, 3, 4, 5. 2 raised to 5. So now you have got the prime factorization of both the numbers, 24 as 2 cube into 3 and 32 as 2 raised to 5. Then what is the HCF? HCF of 24 and 32. How have we defined the HCF? HCF of two positive integers is the product of the smallest power of each common prime factor. So now there are two prime factors here, that is 2 and 3, but it is of each common prime factor. Which is a common number here? Only 2 is common, and what is the smallest power? Is 3. So HCF is 2 cube, which is 8. Now what is the LCM? LCM of 24 and 32 is defined as the highest power of each prime factor, no matter it's common or not common. So you have to write the highest power of each of the prime factor. You need not look whether it is common or not common. So which are the prime factors here? They are 2 and 3. So both of their highest powers we need to find the product. So that is 2 raised to 5 into 3, which is 96. So this is our HCF and LCM. Now there is one more condition relating this HCF and LCM, and that is HCF of two numbers A and B into LCM of two numbers A and B is equal to the product of two numbers A and B. This is a general formula which can be used to solve many problems. So it is very important. You should memorize this formula. Now this is true for only two numbers, not three numbers. Here A and B are the two numbers. So always remember, this condition is true only for two numbers. So that was all for today's class. Now in the next class we move on to our exercise 1.2. Till then,